Hello, so I had a couple of questions about question 15. Question 15 is basically acting like a switch. Okay, so remember, if we look here, if the switch is open, so like looks like that, so it's not closed, it's open, that means we've just got a gap in the circuit here. Okay, so that means we've got a really big resistance. Okay, so that if we've got a huge resistance, like a gap in the circuit, then that gets all of the voltage. So it would get the entire 5 volts. Okay. So if it was closed, then it would have very tiny resistance, almost no resistance. So if that was the case, if that was closed, it was just like a wire, then that would basically get nothing out. It would get 0 volts, and the resistor would get the rest of the voltage. Okay. So question 15 is similar kind of thing. So instead of a switch, we've just got a gap in the circuit. Remember, a switch is just a gap in the circuit. So it says, part A, what is the resistance between A and B if the wires are dry? So all it's meaning is it's a really, really big resistance. So really big resistance. Or you could say huge resistance. Okay, because if it's dry, it's just a gap. Okay, it's just a gap in the circuit. B, what is the potential at B if the wires are dry? And explain your answer. So basically, what it's saying is if the wires are dry, we've got a gap in that circuit. Okay, so we've got a break in the circuit. So this is a huge, huge resistance. So that would get all the voltage, and that would get basically none of the voltage. Okay, if it's that big a resistance. Part C says what happens to the potential at B if the wires get wet? Okay, so if water fills the gap. So if water fills the gap, that means we've basically our resistance has dropped dramatically. We've got basically 0 resistance there again. Okay, so if water's in that gap, then that, because it's got 0 resistance, it's got 0 volts, and that would get all 5 volts. Okay, so remember, resistance is a barrier to the current, so barrier to the electricity. So resistance is a barrier, and the bigger the barrier, the harder it is to get over. Okay, so if if R is bigger, then the energy required to overcome that barrier, so the voltage, remember the voltage is always the energy, is also bigger. So the bigger the resistance, the bigger the voltage across it is. Okay, hopefully that's explained a few questions on that one.